In this video we'll show you how we can import the IGES file into the PM3D and then take the faces through to the machining module for milling and then through to the simulator. Okay, so I've started PM3D from the desktop, so if I open the IGES file, okay, that's the part there, which is okay. And we go up to here, export all XY faces. We're going into the milling software and we can set up the origin to be the X minimum, maximum, Y and Z and so on. We can always change this later on if we want to. The defaults here, you can export as millimeters or inches depending on what units you're working in. Okay, so that's creating the CNC file for us, and it tells me it's done that. And now if I want to launch the CAM system now, I say yes. Okay, so here we are in the CAM system, and that's the part that we've got there. Now it may be that you need to move the datum. I set it in the center of this part at the midpoint in X and Y, but it could be that you want to set it somewhere else. So to do that, I'll show you how we do that. We go into Setup here and we go into Origin. So this is where the origin is at the moment at 0, 0, 0. Now if we choose, we can type in the values of where we want the origin to move to, but if we don't know the values we can select with the cursor. So if I choose this icon here, and then currently it's not snapping to anything, but if I right click the mouse I could set the new datum position to be at any one of these positions here. So in this case I'll select near a point in a pattern, because the point that the pattern has been created for this if we wanted to drill it. So you can see how the cursor is locking on to that point there. If we did another one which was at the extents of the geometry, then that would take the extent in X and Y and make the datum that point. So we may want to do that, or we could do that at the other end. So we can set up the datum to be exactly where we want it to be using any one of these filters. So once we've set that, it actually tells us where the datum is relative to the midpoint of the part. Now to get the datum to move to that point, I need to check this box here, align the geometry with the new datum and reset it to 0. When I do that, the datum position is now moved and you can see the two datum lines there. Okay, so we need to define some tools and then tell it what to do with those tools. So let's define a tool, and let's say we want, if we wanted to machine that small hole first for instance, let's say we want a 6mm diameter tool, set the length of the tool to something sensible. The cut depth here will be used if we cut deeper than 20mm. The system will automatically put in a number of passes in Z so that the cut depth isn't reached. Okay, so that's just a standard end mill, 6 diameter, 25mm long with a 20mm cut depth. Click OK, and you can see that that's now put a definition in the tooling definitions window here. So we simply go through and set the number of tools that we want. We can set up all the defaults for all of these tools and so on. So we can do all of that. If we've set a lot of tools in there and we want to save them away, then we simply go to Tooling, save the tool file, give this tool file a name, and then we can set that as the default tool file whenever we start the CAM system again, or we can call up any tool file that we want. So having defined the tools, we now need to select them in the order that we want to use them. So let's suppose we want to machine this hole first, so we select the tool for that. So we use M6, which is a tool change, and the tool we want is tool number 1. We set the spindle speed and the feed rate to what we want here. There's two feed rates, principal feed rate in X and Y, and a Z-axis feed rate. So normally that would be slower than the XY feed rate. If we've got coolant control on the machine and we want to switch it on, put out an M8 command, then that's what we do here. So that's selected that tool for use, and now we need to tell it what to do. So we'll just use a simple area clear. It needs to know the name of the contour, so a contour has been created automatically for us for each one of the features within the shape. So I want to choose that one. Now as I hover the mouse over there, you can see that it's also given me a direction. So we need to set the work surface and the depth. So if we want to start machining at 0, we set that to 0, and the depth of the contour is that. And that's pretty much all we need to do on there. Although one thing we might want to do is machine out from the center. So under the Options tab, if we say Machine Out from Center, okay, then that machines that out. And at the top here we have the tool view and the drawing operations here. If we simply run the program, then we can just run the tool down so we can see what it's doing there. Okay, so that's just machined that out. If we view the tool envelope from the plan view, then it just blocks it out for us so we can see that it's machined everything. So now we machine, select the next tool. It's be tool number 2. Select the spindle speed and the feed rates for this tool. Switch on the coolant if required. Okay, so now we're going to do a contouring operation, which is round the outside of there, which is called go round. So we need to know the name of the contour we're going to machine. So we need to know that one. So here, as it's showing me the arrows, therefore I know the direction is forward or reverse. So if I want to change direction, but it's also I can check that my offset, the tool is being offset to the correct position, in this case to the left. We want to start off at 0, and the depth of the contour is whatever you want it to be. Automatically there's an approach and a runoff assigned to this shape. So the approach, the automatic option is arc, but you can set that to be something else. If you go to normal, then you just get a line 90 degrees to the direction of travel. Arc gives you a straight line and a tangential arc onto the component. Parallel is parallel to the direction of travel, or rectangular gives you 2 linear moves and an arc approach. So you can change these as you want to. The distance is calculated from the tool diameter plus a bit. And the same thing with the runoff. The default is an arc. And you'll see what this does in a moment. Okay. Oops. So whenever the cursor is in the graphics area, you can use the wheel on mouse to zoom in and out, and if you press down on the wheel, then you get a drag function. So you can move it around as you like, set the tool drawing to what you want, and then run it. And if you want to animate the tool, then you can do that. Okay, so on the right hand side here you can see a status panel which shows you where the tool is moving to in X, Y and Z, and it's also giving you an estimated cycle time based on the amount of travel under feed rate. Okay, so in this movie the tool may appear a bit jerky, but obviously on your system it'll appear just nice and smooth. Okay, so that's done that. The next thing would be to simulate it and then post-process. So we choose 3D simulation. The machine tool is a standard vertical mill. Okay, so just let me move that box so you can see that. Okay, so this is setting up the stock, which is built up from the extents of the part. If you want to put in your own stock, then you use that, and you can define the sizes of the block. But in most cases it's being built from the extents of the tool path, and that's pretty much all you need. Okay, so go into the simulator, yes, I should say build from extent, shouldn't I, rather than define the sizes, because if I don't put in any sizes, it gets itself into a right pickle. Okay, before I start the simulation, I'll just adjust the screen view so that you can see it a bit better. There we are. Okay, so here we can see the complete machine tool, but if we want to change that over here, we can just switch on the workpiece or go to the machine focus, and now I'm simply using the mouse wheel to zoom in and out, left hand mouse button to pan, sorry, right hand mouse button to pan, left hand mouse button to rotate. So we just manipulate the view until we see it on the screen. And over here on the right hand side we have a report, so that this will show us any collisions, the cutting simulation, the accuracy, you can adjust that, and this can be useful if you have a machine which has low memory because you don't want it to be highly accurate. But running it just shows us the part on the screen. Okay, that's fine. Okay, so once we've got that run, then we can view that in various ways and so on. Going back into the CAM system, when we're finished with that, we can post-process, and this is where we choose the actual machine tool that we're going to use. And then the tool path is shown to us at the bottom, the G-code file that we've created. So we then put that onto a memory stick into the machine or via an RS-232 link. Okay, that's how that happens.